Hey, Mr. Allred here, and here we're going to do some operations with functions, sometimes called combining functions. And in this case, we'll have two functions, say they are f and g. It's possible to perform arithmetic operations because they're really just expressions. So it's possible to add, subtract, multiply, and divide two functions and combine them into one function. So here on the left, I have what we would normally think of as arithmetic for two functions, f plus g. We can simplify that notation and assume that when we combine them, that the input would work in the combined function. And that works the same for the subtraction, multiplication, and division. So the left side here is treating them as two separate functions the whole time, basically calculating f of a number, g of a number, and adding that together, where the right hand side adds the two functions together algebraically and then puts a number in. So let's see how that works. Okay, so I've got two functions here, and they're pretty simple to work with. F of x is negative 3x plus 5. G of x is 7x plus 11. So we're going to say f plus g of x. So there's no real new input here, so we're just going to say that we're adding the functions together to get an expression. So negative 3x plus 5 plus 7x plus 11. And if we combine those, we can combine like terms. So that function, when combined, will look like 4x plus 16. So now we know what f plus g looks like, 4x plus 16. So the next row we say find f plus g of 4. So we will just plug that 4 in. We'll get 16 plus 16 is 32. So we could have plugged that 4 into f and into g and got two separate values and then added them together, or we could treat it as a combination to begin with and then plug a number in. And it may not seem very useful with one set of functions or one calculation, but if you were doing calculations repetitively with the same functions, it would be nice if you got it as simple as possible. So let's just do here f minus g, so that'll be negative 3x plus 5 minus 7x plus 11. So this combined function will be negative 10x minus 6. So if we were to plug negative 5 in there, let's see what I get. I get 50 minus 6 would be 44, I believe. You can check the math on that. If it's wrong, just let me know. So that's addition and subtraction. Multiplication, division. So f times g, that's negative 3x plus 5 times 7x plus 11. That's going to be a FOIL. So let's see here. Negative 21x squared minus 33x plus 35x plus 55. I'll combine that under here, and it'll be like negative 21x squared plus 2x plus 55. So I'm combining like terms. So if you can multiply that together once and do one calculation, it's better than doing several and multiplying each time. But we're going to plug 2 in. So negative 21 times 2 squared plus 2 times 2 plus 55. And I told myself I wouldn't need a calculator for this, but let's see here. So it's 4 times negative 21 is negative 84 plus 4 plus 55. So negative 80 plus 55 will be negative 25, I believe. So f divided by g, just keeping the functions together. There's not much you can do here. It'll be negative 3x plus 5 over 7x plus 11. There's no real arithmetic you can do there besides writing them that way. And we're going to plug in 6 to get a calculation, just a random number. So when I plug 6 in, let's see, I get negative 18 plus 5, which is negative 13, 42 plus 11, which would be 53. There's no simplifying that. 13 is prime. So there's one more thing we need to talk about here, and that is domain. So considering that we are taking two functions and combining them, we really need to take into consideration the domain of the functions before we start, because if something doesn't work in f, then it shouldn't work in f plus g, even if something cancels out. Or if something doesn't work when you combine them, then you also need to take that into consideration. So just right quick here, we'll do a couple examples, but f of x was negative 3x plus 5. Remember, that was all real numbers. There were no domain problems there because there was no root and there was no denominator. G of x was 7x plus 11. That also does not have any problems, so all real numbers work. Numbers, not number. And f plus g was 4x plus 16. So everything worked in f, everything worked in g. So I can look at f plus g and see that it's still just a straight line. All real numbers work here. Now, where you're probably going to run into some real problems is the division, because now you're creating a situation where you could divide by 0 even if you weren't to begin with. So the function was negative 3x plus 5 over 7x plus 11 when we say f divided by g. So everything works in f, everything works in g, but when I put g in the denominator, then I have an issue. Remember that, whoops, the denominator can't be 0. So this 7x plus 11 cannot be 0. So it means x cannot be negative 11 sevenths. Okay, so that's the domain of the quotient of those two functions. Alright, so let's use two other functions and see what happens here. So the functions are going to be f of x, which is 3x plus 7. No roots, no denominator, so that's all real numbers. And the other one is g of x equals the square root of x minus 5. So that's the square root, so that has a domain issue, meaning x minus 5 has to be greater than or equal to 0. So that means the domain has to be numbers greater than 5. Okay. So when we do f minus g, it'll look like 3x plus 7 minus the square root of x minus 5. And regardless of what happens, we look at the original two functions and we couldn't plug numbers less than 5 into g. Well, that's the same thing that happens here. So it picks up the same domain as up there. You can only use numbers greater than 5. Now g divided by f. Now in the previous example we did f over g, but we can do g over f. So there's g, x minus 5, over 3x plus 7. So we got two things here. First of all, we have that x has to be greater than 5 from the original g up here. And then we have the issue that the 3x plus 7 cannot be 0. And if we solve that, we get x does not equal negative 7/3, which lucky for us is less than 5. So, but there's no telling. This thing down here on the bottom, any number could have broken it down, but the domain in the end is greater than or equal to 5. Okay, but putting the other function on the bottom could have changed it. Okay, could have caused us to throw some other number out. But that gives you a sense of how combining functions have a new domain.